Where are we?
East Grinstead.
East Grinstead, yeah. That's in Sussex, isn't it?
West Sussex.
Well, it doesn't matter, it's Sussex. So we're here in Sussex, taking an early morning journey around the M25 to come to Satherly Designs, which is just here, and we're going to meet Richard Satherly and Ian Povey, who contacted us and basically asked us to come along and have a look at some of these items they have for potential donations to the museum. So let's go and meet them. Hello, Richard. Yes.
Hello.
How are you? Great to meet you.
I've been waiting for you.
Oh, thank you very much for taking the time to stay in and wait for us.
That's okay. Come on in.
Okay, thank you.
Right, please take a seat.
Okay.
Let's get on with it.
Nice to be here. Nice to meet you. So, this is the Logica VTS 2200. Can you tell us a little bit about it, because you were very much involved in designing the case and making this?
Yeah, well, that's it.
Right. Well, how does this happen? I mean, so you're an industrial design?
Yeah, I'm a New Zealander, right? So I came out for postgraduate study at the Royal College and graduated. Decided to join Carlton Communications. This is Michael Green and such. And in the design unit, we started off with doing product design for a number of different clients. So when they closed it down, he said, "That's all right. We just want you to manage it and run it down." Of course, what that gave me was the access to potential clients.
Mm.
So within the year that happened, and one of the potential clients came out of one of the secretaries that worked with David. His husband that worked with Logica, who were up in just off Oxford Street. Mm-hmm. So I went along there and they employed me to do this for them, right. Which was literally, go for it, Richard. But I'd come out of an apprenticeship in New Zealand with Fisher and Paykel, who are appliance manufacturers. And literally my experience going to the Royal College was production engineering. Mm-hmm. So I could pick it up easily, and with drawing boards and all of that for those days, this is where this started. When I left Carlton Communications, I took some space in Covent Garden in Dryden Street, 5 Dryden Street. And in 5 Dryden Street, there was a 10 square metre space that you rented. There was enough for me, the drawing board and the filing cabinet with all of the contacts in, which is what my agreement was with David, that if when we left, that's what I get, and a chair. And that's where it all started. They employed me to get going. I gave some sketch designs, which is in an article that is here for you. Because of Dryden Street being a working cooperative for people starting off in business and so forth. Mm-hmm. Your space was, as I say, very small, and I needed to make models. Right. So I ended up making models. And there's the monitor.
Okay.
Which is polyurethane foam. Dangerous stuff because the dust, if you swallow the dust of that, it's not very nice. It's stuck together. What I did over a weekend was I stuck some blocks together and started to carve it.
Right, okay, so it is hand-carved?
Yeah, it's hand-carved. I went through 2 art schools, Elam in New Zealand and Michaelis in South Africa. Uh-huh. And sculpture was, along with production engineering, is my strength.
Right. That is incredibly symmetrical. It's something hand carved.
Yeah, well, you can see the blocks. You see the
you see the joints down it. Yeah. But then that was the way that a client got to visualise what this thing
3D, so they could touch it.
Because this is obviously way before any kind of computer modelling and
that's right.
So somebody else come up with these these drawings?
No, they're all mine.
They're all yours?
I didn't employ anybody. It was a straight project start.
Right, okay.
Yeah.
So Logica created the first electronic typing pool for Unilever.
As far as I know, yes.
Yeah,
But
so it says online.
Right. Yeah. But I was focused only on doing this project.
Yeah, but this project came out of that.
Yes,
The typing pool. People will be using this for quite a long time. Sitting there typing all day in the typing pool.
Yeah. Which prior to this coming on board was the IBM typewriter, which we did acoustic housings for IBM typewriters because they're too noisy.
Yeah. This is effectively just a word processor.
That's what it was.
And to see something this kind of scale these days, that is just a word processor. I mean, you don't buy word processors anymore.
Right.
Which ultimately later on would be its downfall, but that's the way technology moves on. So Logica come to you and just said, design me a word processor.
Yeah, with these elements, with the hard drives and all the rest of it, the power supply and PC boards.
So the PCB was already designed? Or did you have handy making that?
It was no, not at all.
Right, okay. So they come up with a PCB, said, right, this is going to be the size of it.
That's the size of it at the moment, and subject to the design, I would change the outline.
Right, okay.
Otherwise, so along with them, not in isolation.
Yeah.
So it was totally working as a team with their people and my own attitude towards it all and so forth. But
But then certain things couldn't be changed, so things like these disk drives were completely standard.
Right. And in moulding, of course, it's not injection moulded, where you get down to very thin walls. It's polyurethane. And of course, to find a subcontractor that could mould them as well was a problem in those days.
Right. So why? So this isn't a standard sort of ABS case.
No.
This is what material did you say?
Polyurethane.
Polyurethane. And why was it polyurethane?
It's injection moulded polyurethane because you get low volume.
Right. Okay.
And the tooling could be aluminium, and you can get low volume quantity of the mouldings.
Right. Okay. So I mean, bear in mind it's Logica. They were a big company.
Oh yeah.
Why was it a low volume thing?
Well, because they did. Well, don't ask me. Ask them.
Right. Okay.
That's their market.
If I could. Right. Yeah. Okay. Yeah. I mean, it would have been very early days.
They grew because, as I say, that's the first generation. That's second generation.
Right.
Second generation, I dealt with them down in where is it? Down south. They'd moved out of London altogether. As you say, you noted that they've got very big. So I was still involved with them. So that's where the second generation comes from up there.
Right.
That lot there, injection molded. This is polyurethane molded.
What were the design factors in this? I mean, are there elements to this that were controlled by any other third parties? I.e., is the height of this anything? Did the monitor sit on top of that, or did it just sit on the desk?
It sat on the desk. Likewise.
Okay, so this unit quite often sat under the desk.
Yeah.
With the monitor and the keyboard.
So there you go. You can see that I've got fans to deal with, I've got the hard drives to deal with, I've got printed circuit boards and power supply. You've got to put them in some sort of configuration, which is a normal design process anyway, even today.
Yeah, absolutely.
So you do it on computer.
I mean, one of the things is heat as well. So you've got a power supply in there, you need to get the heat away from the main board.
That's it.
There's all those sort of practical considerations you've got to make.
Well, that's like Tadpole, that's why we went to magnesium, literally to get heat dissipation.
So the case acts as the heat sink?
That's right.
Interesting, we'll come on to that.
Yeah, we'll lose it. You're forcing me to remember a hell of a lot that I've forgotten.
Oh, it's interesting stuff. You haven't forgotten it. It's in there. We're getting to it.
You're going to have to dig it out.
So, we've just talked about these photographs. You've just taken them out, and your comments are quite interesting. So, this is a design that you've done. Was this for the VTS? Or is it just another general?
I think it was another general because by then things had started to happen.
Right.
And other companies were getting involved with creating competitive product.
Right.
Which involved casing the hard drives and having VDU screens.
Okay.
Which is what I'm showing you here, like that fellow there. I've got the foam models galore here of me working to get that one sorted out, which is a dreadful design.
Well, I mean, you said that about these. You said yuck. And I have to say, I agree.
Good.
But what makes that yuck?
Too busy. Not simple enough.
Right, okay. So simplicity has often been a sort of a key in design. But so what's too busy on there?
All of this lot here.
Okay, so the bit down the side. Yeah, you see
And
that on lots of computers.
and the offset here as well.
Yeah, for me, it is about that screen.
Yeah, and the fussiness around the screen.
Yeah. It kind of seems like it wants to fall over that side. You've got something that's off balance there.
If I remember,
it's interesting how design makes such a difference.
Yeah, if I remember correctly, at that particular time, you're prompting me now. In the back of my head, I'm remembering Olivetti was. There was a big exhibition of Olivetti's up in King's Cross, and I think that was the influence of this sort of thing here, where I ended up being influenced by Olivetti's corporate stuff and doing designs that didn't fit their purpose. Because what was the point of having this bloody shape and fitting a keyboard into it? It's just a dust collector.
Right.
So that's where things started to change. So here I am here doing stuff that looks very artistic and nice, and it all fits together. But the usability of it all is rubbish.
Right. Okay.
So for me, it's these days when I look at it and what I do today is quite difficult to get it. There you go. There's me working in the conference room over the weekend, creating models, until I employed a guy called Peter Bessie. He was my first employee, and he kept sticking his head over the screens in Dryden Street, telling me what he thought I should be doing. So instead,
is that appreciated?
Yeah. I got to the point whereby I got so pissed off with the fact that he was trying to tell me what to do. I employed him. I employed him.
Brilliant. Yeah. Okay, so this is the next in line. So after the BTS 2200. So this is a later version of the same machine. So it's still a word processor, still basically the same system, a little bit more slimline this time.
Yeah, but it's injection molded this time.
Right. So we've gone from
from a polyurethane.
Yeah.
From a minimum wall of 5 millimeters, you're down to 2.5, 3. That's injection molded.
So what would be the tooling for something like this back in the day?
Pass.
It's got to be.
Don't know. Ask.
You didn't have to worry about that.
No. No, because they're an R&D development.
So Logica.
And if you've got no. It's within a client's base. If there's experience, they know what it is to spend because they've been through it before.
Right.
And the only differentiation is the involvement of a designer from an ergonomics or a usability point of view, making the difference between them and their competitors. So you do an analysis of the competitors out there and you see where the differentiation is. You come back and you design the differentiation to get your leg in and differentiate to get bigger volume and better slice of the market. You see all the drives and
they've gone from full height drives down to a half height drive.
That's right. And this would be half of I'm quite sure one of the major reasons for redesigning it as well. Because the power supply's in there and more boards are in there.
This one's a little bit grubbier than the other one.
Yes.
This feel to it, where it's got that tiny pitted surface.
Yes.
What's the thinking behind that?
No, it's not deliberate.
It's not deliberate. So is this just a way that it's moulded? It's just a.
To be honest, I can't tell you. I don't know, but it should.
Because a lot of machines have this, and again, it makes it a nightmare for us to clean these things.
Yes.
You can't just wipe it over; it gets into all the pits. Going back to the time period in which this was designed, and the cost of injection mouldings. How did you know that your design for the case was going to work as an injection moulding design?
Because I know how to do injection mouldings.
You haven't always known how to do injection.
I have. Before I left New Zealand, I worked with Fisher and Paykel, and Fisher and Paykel produced refrigerators and fridges and washing machines and all that stuff.
Right.
And I can remember one of the last project that I did was a cover for inside the refrigerator. There was a cover anyway.
Right,
It was an injection molded cover that had lights behind it and a lever.
Okay.
And so it's injection molding. They taught me how to do all the considerations for injection molding.
Right. Because the rake on a mould, is it? Or this is from school. Draft?
Draft.
So draft angle.
Draft.
So when it comes out of the mould, it comes out. So it's actually very slightly narrower at the top than it is the bottom.
That's right.
Oh.
Well, you can see that here.
Yeah. Right.
Draft angle.
Yeah. Right.
Well done.
So I learned that from school. I did learn something at school.
You did.
Fantastic. But that all has to be taken into consideration because there's lots of edges to this that I would have thought that would make that difficult. How sort of bits like this work. I mean, today again you've got. I know a bit more about PCB design,
yes.
and now when you create a PCB. You can actually have all the components on it, so you can see height and everything else. I remember designing a PCB, and it was to fit in. My company didn't have the ability to go out and get a case design, so we used kind of project boxes and made them work for us. Yeah. But once I've made the PCB, the components were too high to fit the lid on. Now I've got software packages that will put the component on it. You can see height, you can see everything. Yeah. You just didn't have all that back then. No. So a lot of this was, I'm assuming, in your head. That once you've done your designing, which has all been on paper, that understanding how this is going to fit together is
it's basic principles. It's easy.
Is it?
Yeah, it's very easy.
Okay.
Because you've got a certain amount of depth that you can have, and that's about it. Right. That's why you've got to break it up. Mm-hmm. This is drafted down here, and it's drafted down the bottom, and make it easy for the inserts to be put in there. Mm-hmm. Yeah, and it's stuff like this. If you see the back here, by nature of this whole hood, right, allowed in one tool to get the venting as well. And of course, the venting is an insert in the tool because you can see the split line around the edge. Right. You've got this bit here. Yeah. A good designer will consider all of the technical constraints that exist in getting the end product. A bad designer is one that does a pretty picture and leaves the problems of making it work up to somebody else.
The engineers that are
that's right. Right. So that's the difference. And if you know what you're doing, you can actually do some nice detail in injection molding with the injection molding restrictions on it, and that's important.
There were so many small companies, and well, still so many small companies.
I'm sure
that can't afford. Well, in software, but back then in hardware, that were knocking up machines, just knocking up a ZLT-based computer, and thinking this is going to be, just going to change the world. But they don't have the ability, the finances to create a case. So it literally goes into a metal box with a standard cherry.
That's where excuse me, this is Satherly Design. I think you've got a product here, and the reason why I'm coming to see you is because we can do this sort of thing here. Yeah. And I do a picture, you see, and I show you and try to convince you to spend some money on industrial design.
Yeah, absolutely.
But that's literally what happens. Yeah. And it still is today.
Because it's got to be a partnership between having a really good product and making that product look good. I mean, if you make a terrible product look good, it's still not going to sell. Yeah. Well, actually. No.
Actually,
I could name a couple.
Interestingly, when was it? Not that long ago. I was invited to a meeting. I'm being careful here on who I say it with. I was invited to a meeting, and it was to do with doing a project. And this particular project, the basic principles were that I'd reached the point where I decided that rather than go and get into a project and then tell them the truth at the end of the day that they're going to have to spend this extra if you like it. So what you did was you did a very good design, you love the design, you raised the money to spend to make it a reality. Mm-hmm. And in this particular interview that I had, I was too long in the tooth. And I listened to this, I shut up he knows I'm always on about, shut up, let the bloke talk until he's finished, and then you can contribute. Mm-hmm. Yeah. And I let him talk until I could contribute, and I just got fed up, and I said to myself, oh Christ, he's going to be an absolute bastard to work for, so I'll tell him the truth. It's going to cost you £30,000 tooling. It's going to cost you £15,000 to £25,000 design fees. And at the end of the day, you'll have a product that you can produce for X number off and so forth and suit your needs as per the brief that you've told me. Mm-hmm. He said, that's expensive. I said, well, then you can't afford to do it. Mm-hmm. I said, thank you for seeing me today. And I walked out.
Just like that?
Well, it's going to be too much hassle. Too much of a problem to spend convincing him, but it's not only him, it's employees as well. And that's why they bring a consultant in. Mm-hmm. And I just decided I'm getting too long in the tooth. What I need to do is tell them the truth so they don't waste people's time. Mm-hmm. And that's what happens today. Mm-hmm. And, it's really funny what a client They went on Dragon's Den, and Dragon's Den, they did their asking the questions and so forth and so forth. And I've got fed up with it because the fees that they're asking for is a load of rubbish. You know, if you want 70,000 quid, Jesus, spend it. You've got to get on with it and take the risks. Dragon's Den, 70,000 quid's nothing. It's a drop in the hat. And when this particular client of mine came along, and we're still working with them and today, but this was three and a half years ago. Told them that they'd already spent £2 million in development. So you'd seen that you reacted there with the draw drop. But that's actually what it costs for something that doesn't exist already in the marketplace out there.
Coming to existence.
Yeah, where you're going to become a competitor with similar products, you can. But when it doesn't exist and you've got to get it right, then you have to spend the money. Otherwise, what's going to happen is you're going to fall over backwards, because you get a problem out in the field and somebody sues you, you've had it. So you've got to prove yourself as you go down the line, and that costs a lot of money.
Yeah.
And this particular client's done very well from doing just that. But the Dragon's Den were fools unto themselves, but the client did it for a good reason, to get exposure.
Oh, yeah.
So you got
you've got to question
TV exposure.
some of the reasoning for people going on these.
Exactly.
No, it's a great platform to get you.
When you're in the business, or that they're talking about, I know they do different sorts of business, but if you're in the business of what they're talking about, you can see it. Boy, oh boy, it's going to cost you a lot bloody more than that.
Yeah, absolutely. No, it's a good platform just to get the name out. Everything else, what happens is kind of irrelevant, isn't it? This is an interesting machine. It looks like this was a terminal, so it would have had a keyboard. We haven't got a keyboard for it though. Can you tell me what it is?
This is for Newbury Data.
Newbury Data. So this is not Newbury Labs. There's another company, because there's two Newbury company, Newbury Data. But anyway, so this is a sort of just a VDU. It moves brilliantly, just the way that you can adjust.
Well,
so there's clearly
you've got that as well, and that is
but it's the way it does that.
Yeah.
A lot of monitors have got the swivel bases, but
that's right. At that particular time, ergonomics was high on the list.
Right.
So it became an issue that you be competitive out there, because everybody else's units were all stable and ergonomics was in play, and people were sensitive to colour on the screens and visibility of the screen, and of course visibility in an office. So if you're sitting in an office and you've got the sun or whatever, you can move your things around, and all of this works.
Show the customer data or whatever.
So my engineers at that particular time took the bloody thing and put a design details in, because you can see in here these are just visual supports.
Yeah.
So what I was doing was making sure I was a bit like a hand. So the cup underneath there is the hand, but everything else, all the cables go down inside, and it's all lightweight, calculated weights.
But there are no cables.
The other inside.
Yeah, I know. But that's nice, isn't it? It's all there hidden away. You can just about see the cables at the back there. Yet the cables must go through
processor boards, and you can see that this unit transposes and goes onto.
It just sits.
Sits.
Yeah.
So you can have the height adjustment or not, as the case may be. So you lose all the back end, and you put the monitor on the disk here.
Right. Oh, I see. So it doesn't have to have all the.
Doesn't have to have
arm
the
and everything.
No, that's right.
Oh, I see. Because that probably has quite a lot of cost to the product.
Well,
to have it. Or did it come with it?
I'm sure it did.
Right.
I don't know exactly, but I'm sure it did. But there would have been applications that didn't require so much ergonomic manipulation changes and so forth.
Right. So did this go into production?
Oh yes.
Yeah.
Oh God, yes.
So this is probably in fairly stark contrast to the Logica VTS. Ergonomics wouldn't have been a thing at that time. Just the fact that
it was there.
It was, okay.
But people weren't prepared to pay for the extra for it. It's the same today. People won't pay extra for the little bits that make the difference between one product and another.
Right. Okay. So these photographs are done by you to show to the client. Well, this is going to look like, or is this done for marketing purposes after the? It's
marketing purposes for myself, and that can be used if the client wants to. If he wants to pay for his share of generating them.
Yeah, getting photographs done of this kind of standard.
Because in the design practice at that particular time, I was building up in terms of numbers. and we need to produce brochures, which is what I wasn't doing previously. But these are all brochure shots and so forth.
We've got another version of it at the back here.
That's the same product, it's just been painted a different colour. It's me mucking around.
So why paint it?
Just to see what happens. See a different version.
Different version.
Experiment.
For why?
Well, if I thought it was worthwhile taking to the client, because what I'm doing here is, see, traditionally in those days, the front fascia had a different colour.
Yeah.
And everybody's unit had that. So for me, it was like, hang on a second, why do we have to have a different colour in the front? Ergonomics, yeah, okay, but what if we just continue it at the back? What does it look like? What you've got here, of course, is a dense colour at the bottom, which is heavy, which is supportive, and you've got the green sitting on top, and it's one unit sitting on top by itself. So it's supporting, and it's just saying more what I do than it would normally do under these circumstances.
That's incredibly interesting, though. I mean, it's just the colours. Well, yeah, because you just said that the darker colour, which is supportive, a colour being something that has kind of a structural message to it is really interesting. And then you've got the whole monitor is coloured differently, and it's a lighter colour, so it seems like something that can be supported by the blue colour. It's kind of, I mean, as an end user, you never really think about the fact that these colours are there for a reason. You know, the darker colour is that more supportive colour. It's just really interesting.
Or competitive differentiation as well.
Yeah.
There's that aspect to it.
I mean, they would have been unusual colours as well back then.
So, absolutely.
Did the client see it?
I can't remember.
Oh.
Well, it didn't go. This sold.
Yeah. So, but this would have been acceptable.
Yeah. Well, if you create colours like the one in the back here, and show the client as well, then the client is more inclined to go with what he feels safe with, and what he took a decision on earlier, and wasted my time. So long as I cover my backside on what colours I put up, then we get this through, and everybody's happy.
It's happy anyway.
But you've got to come down to a common denominator. I digest, but no, it's acceptable to more than one. And once those colours are set, then we're in production.
Yeah, interesting. Again, it's something that you don't really think about in product design, especially in computing. The colour plays such an important part in the way it's perceived. So, this is the ICL DRS M15. ICL, big British company making lots of computers for UK corporates, worldwide corporates actually. And the DRS was a distributed system, so these were terminals that connected to the mainframe. So how did you get involved with ICL?
The original introduction, which is the case with most clients, is there was a project on, and we were invited to tender for it, and we won, and we did the project. But during the development of that particular project came the opportunity to be more constructive from a design point of view. You can imagine they've got development teams in all locations. So it's got people doing retail, you've got people doing PC division, and you've got people doing mainframe and so forth. They all have to make decisions about the physical design of the product and the appearance of the product. What was happening was it was all over the place because too many cooks. Exactly. And what happens is that the designs coming out were scattergunned all over the place. In the background of all of this was Apple. Coordination between products was strength. So what comes next is the product identity.
Is this a document that you've produced to tell ICL?
I didn't produce myself.
Or Satherly Design produced
it.
For ICL to say,
for
this
ICL.
is the ethos for design for your products.
That's right. So here you go, here, standards for physical design.
Even the manuals look nice.
So that's how to do labels. So every division did the label the same way. Which saved money. And gave better strength, corporate strength.
So this kind of brand guideline is pretty standard now. But back then ICL had nothing that said this is how it was going to be. Right. Okay.
So it's not just labels; it goes down to packaging a lot.
Right.
So here we go. Here, this is the next one.
Visual identity. Okay. So this is how the manuals are produced.
This is showing people how to produce the manuals.
Yeah.
And everybody to be consistent.
Typefaces, the
doing
layout.
so, which saves money. You start to see the product.
Mm-hmm.
And retail. Marketing.
Okay.
So literature. Again, consistency.
So this is how the marketing is going to look. So that all brochures have that kind of same feel to them.
Yeah.
You know, it's an ICL brochure before you even
here's a good example, if you go back a page.
Mm-hmm.
Right, this was existing product.
Right.
So where they weren't prepared to spend money on redesigning it
Mm-hmm.
and bringing it up to date and just leaving it as it is, for good reasons, of course, but the badge remained consistent with everybody else's badges.
Okay.
So that there was a unifying...
you couldn't spend all the money on redesigning the
right.
original system, but you could change the badge on it
That's right.
to bring it in line with everything else, right?
But again, the physical design language was consistent as well. So each time there was a new product being upgraded or otherwise with new hardware, because the drives got reduced in size
Yep.
to be floppies.
Yeah.
And of course the hardware package had to change.
Mm-hmm.
And changing the hardware package was the opportunity to get the physical design to coordinate
come in line
as well. Yeah.
with the guidelines, right?
Yeah.
Yeah, this is all the behind the scenes. The customers just end up with a machine. They take it out of the box, they plug it in, and away you go.
It was 30 years ago.
Yeah, so.
What not to do, what to do.
Mm-hmm. I didn't actually realise that ICL was part of STC. It must have become part of STC later. Colour schemes. Well, that's some colours.
Mm.
Okay, so who's this guy on the front here? Peter Bonfeld, chairman of ICL.
And one of the things that's so always inconsistent is a symbol for a keyboard.
Right.
And so it was just so interesting that that should be inconsistent. So right down to little details.
It's even
these are the
international standards and the model numbers and everything else, even the layout of that.
That's right.
Drawn up completely.
So this is where design takes on involvement in other areas as well.
Mm-hmm.
And that's what ICL was. We were doing all the hardware design as well.
One of the things that isn't represented here is the actual software.
No.
So that was left to...
I haven't got a clue.
Because so much of it, I mean, it's now part of software.
I know.
But I suppose back then you didn't actually have a lot of choice anyway, because you were dealing with, basic graphics on the screen. There wasn't a great deal you could do anyhow to better define the hardware defined how it looked.
To be honest, I can't rightly remember. I don't remember getting involved with the screen graphics.
Yeah, they would have been limited. But so this as a product, it looks really nice, and actually something like this sort of keyboard would pass today on any machine. The machine itself is really nice and slimline.
You see what I'm doing. What I'm doing with physical design here is like on the other units. Is these vents. Sometimes they're not vents.
I was going to say, are they actually vents?
No, sometimes they're not. But what happens when you do lines like that is you visually lose the bulk of the product. It looks smaller.
Okay.
So, what happens, and you can see it here, as much as I hate this on the basis that having done it, it collects dust and rubbish.
I was going to bring this up. Do you know how much trouble that is to us these days? Cleaning these machines up from 30 years of grunge.
I'm sure. But visually, with the keyboard sitting here, what happens is you'll notice that it's not square, it's all ergonomic. It's all physical design has changed. Even back into the back of the underside part of the board of the keyboard has to have the same attention to detail. So we do triple bits here like
yeah, so the cable can come out wherever you want it to.
Which is
left or right handed, I mean
it's hold the cable in there, which is some stuff that people don't know how to do. But it's just shutting off the tool and creating a hole. But it's a technical high injection molded details.
But all these details do make that model much harder to make. I mean, and injection molding tools are incredibly expensive.
Oh yes, I know.
So
but ICL had the volume.
Yeah, right.
So you get things like this which save time. There's a keyboard, 2 different heights. I'll just get it back in there. There you go. So, one height, second height. Again, ergonomics.
Yeah, absolutely.
And differentiation in product from everybody else's as well, which became a benefit. Same thing.
It's interesting, because to be honest, that kind of thing now, on any standard Dell keyboard is there. But this at the time differentiated the ICL product from others. They hadn't thought of this kind of stuff.
Yeah, well, see, most designers or clients that are in that field, they come and they say, right, design us a keyboard, and there's your keyboard. For me, I said, okay, that's the keyboard there, and the underside will design that as well. And they said, well, why? I said, because it's one product, and we can do things that make you look more professional.
Yeah.
And so this is why this came out of here, and it's all functional as well, because I'm looking after the cable, which was a pain in the butt in those days, because cable management was an issue.
Yeah, definitely.
So, yeah.
It's incredible. I think it was Steve Jobs it was his father that talked about design of a wooden cabinet. You have to pay as much attention to the detail at the back of the cabinet that nobody ever sees.
Absolutely.
As the front of it.
Yes, that's right.
That in practice.
And that's the difference between good designers and bad designers, is that attention to detail and consistency as well. But that gets a lot lost. But of course, I've got to say, that's ICL. And it's STC. They have a lot of money.
I was going to say they can afford to
do it, and to keep themselves differentiated, and also their product looking professional, which is then rubs off on the software and everything else, and the usability. Yeah,
it's the saying back a long time ago was in the States was nobody was ever fired for buying IBM. An ICL kind of was our IBM, or those kind of companies that they were trusted companies. And that obviously allowed them to sell lots of product, but then that allowed them to invest in the industrial design that made their products even better.
Which led to creating products that didn't exist, but to test the market for their existence.
Yeah, because they could do that.
That's right, and that was excellent, because that took stuff forward that otherwise would be thrown out the door, and not touched or not even acknowledged by internal design development people. So the danger here is when a consultant designer comes in to a company, a relatively large company, immediately there's a threat that somebody's job inside the company is at risk, because the design outfit, which was mine in those days, goes in there and people don't have another job. Not at all. My job in those days was to get in there and educate them to carry on the design detail concept and philosophy, as opposed to throwing out people and not giving them a job. And that's where this
and hopefully create.
That's where that became a reference point.
Yeah.
You can do it to different levels.
Yeah.
And that's where I focused in those days. I've got other examples up there, but this is the big fella.
And again, ICL were a big British company at the time, sadly, all now gone. But these were absolutely standard across any big company in the UK. These kind of products were everywhere, and it's strange that they are so far and few between today. Few and far and few.
Well, product design per se in the computer world has disappeared, more or less. Because it just doesn't exist like it used to, and rightly so too, because you need to move on.
So this is something a bit different, a bit more recent than the ones we've seen previously.
Yes.
And this is a Tadpole product, so this is a Cambridge-based company.
That's right.
At least they were for a while. And these things are quite considered to be the absolute pinnacle of any laptop. They're quite unusual. Because they use, as the name might suggest there, Sparkbook. They're using Spark processors, and they use various other IBM RISC machines and things like that. But these are generally used by the government and military and people like that for taking out and demonstrating their software and things like that. So, but these are incredibly expensive. It's about $6,000. I think they are, or were $6,000 to buy one of these things. That was a lot of money, but it's also really nice and actually feels cold. Why does it feel cold?
Magnesium.
Right, so it's not your average plastic enclosed laptop. magnesium case.
Well, magnesium case is to get heat. Well, we decided collectively with the client to go magnesium for the simple reason that there was heat dissipation.
Right.
And you can see what's going on in here. There's all vents and so forth.
Mm-hmm.
But of course, technology-wise, magnesium production in the UK was minimal and didn't have that much experience.
It's quite a hard material to work with, isn't it?
Yes, it is. And so that's where Tadpole located and sourced Chicago white metal in the States, in Chicago.
Mm-hmm.
And so they flew me out there to get down to the basics on what I need to know to be able to design with magnesium for what we were doing, which is sensible because I didn't have the experience. My staff didn't have the experience for using magnesium, but we knew that we needed to.
Yeah.
To get the minimum size and so forth. So, yeah.
So this whole case is effectively a heatsink then?
Yeah.
So then I'm assuming that a spark processor, they were very powerful processors at their time, generated a lot of heat, and we had to get rid of that heat somehow. Well, you had to get rid of that heat somehow. So we end up with a magnesium case. Docking station.
Yeah.
And all of its connectors. Even got SCSI on the back.
Yeah.
That would have been fairly unusual on a laptop at that time. Serial, VGA, all the works there. So then over here we've got an external floppy drive, would that be?
Yeah.
So that's a case for an external floppy. Again, it looks really nice the way it's all been
It's just
feet made into the...
Yeah, it's just coordinated details.
Yeah. Mm-hmm. Very nice. And then, what's that bit over there then?
Charger. Battery charger.
So it's a laptop that you don't see very often because of the sheer cost of them and the places that they were going to. So that's the Sparkbook 3. And who knew that Cambridge company were behind it and Satherly Designs behind the actual industrial design of it. I believe this then, though, the story then follows on through a connected person onto the next one.
George created GeoFox, which is a product that he wanted, produced, to compete with Scion. We did the product design.
Right. So, I read online, and not knowing anything about this, that it was based on a Scion Series 5.
Right.
And used a lot of the same technology, but that added the touchpad. So, don't know if that's accurate or not, but that's what the interweb says.
George, this was the largest flat screen at the time.
Right.
And George was rather determined to make sure that he went to the market with the largest flat screen.
Right.
But it was a large number he had to commit to for this, and that was a purchase that committed him to the production that he had.
Right. To get a price that was affordable, to get the numbers.
Yeah. Had to have the numbers up.
So it's a really nice sort of feel to it. Tiny rubber keys. So it wasn't touchscreen, was it? It was all done through the touchpad. Yeah. Right. But sadly, one of those products that wasn't to actually see a great deal of distribution. There is a couple of reviews of it online, which actually they are reviewed really well. Somebody has got a website, as everybody does, of very specific types of computers, and the one that I did have a look on says that there was about 1,000 made, but probably less than 100 exist.
Right.
And well, 2 more known to exist now.
Well, in as much as they're development units.
Well, that makes them even better.
Oh, okay.
I love me some development stuff.
Right. Good.
Things that other people haven't got and won't have.
Difficult to design because you've got to get down to the minimum walls and so forth.
Yeah, I bet.
And everything's rather vulnerable as well because, like I was playing there, they can break off very easily. It's very difficult.
Yeah. I mean, does that sort of thing make it a pain to work on, or does it actually make it fun?
It's not so much fun. It makes it a pain, but it's a worthwhile pain because it's irrelevant really whether it's a pain or not because that's the brief.
Oh, okay.
So you just got to get on with it. And when you go through the design process, it's a little bit long way different to that of Logica VTS 2200. And you've got to know what you're doing with it. Yeah. My guys did. And we used to have lots of fights because I'm determined to interrogate on the basis of why do you want to do that.
Mm-hmm. And if they give a good answer, you'll accept it.
I'll accept it if it's a good answer. And then I'll say, well, what did you we're talking about going forward now?
Yeah.
So show me the proposals that didn't work in your opinion.
Mm-hmm. Mm-hmm.
And then we start to see the truth come out. So it really is only one. So what are the other ones you've considered, Ian? So what other solutions have you considered for this application? If he hasn't, then I'm saying go away and find some other solutions. For the simple reason that precedent is there. I don't like designers who come in and it's like the fairies that do pretty pictures and say that you can make this very cheaply. It's rubbish. Mm-hmm. So for me, it's each time it's always, okay, this is a very good solution you got here. We're in that position right now, actually. On a project, and I'm saying to him, okay, I don't want to know now, but what did you throw out to get to where you are now? And if I then can evaluate that and see whether it's good, and there's elements of them that may well be better employed with the final solution, then we're going somewhere.
Right.
And not only that, but we can be interrogated by the client, and the client can stand up and be answerable for what we do. Mm-hmm. Very, very important, because there's so much of that out there that isn't done like that.
Right.
Yeah.
So it's just as important to use the designs that don't work as the designs that do work.
The designs that don't work have aspects of them that do work, and it's the combination of those features that isn't going down the right road for whatever reason. It may be money, it may be function.
Aesthetic or whatever.
Aesthetic, that's right. So you've got to weigh it up as you go down the line. And that activity actually, just to break off into just product design and development, particularly in the consultancy, is very difficult to sell because clients don't want to pay for it.
No.
So I have to take a choice.
It didn't come across my mind. I didn't know I was brave enough to say it or not.
Yeah, but that's right. They don't want to pay for it. Yeah. If they did, what they get at the end of the day is the security of knowing that they've been down all the avenues available to them to test what they're doing, given the time frame that they have. If they've got a large time frame, great, but if the time frame's short, then the consultancy should do whatever it can in that short time. But that's the time when you stop, you take the risk, and you move forward, if there is a risk, indeed. Yeah. But that's the real world, as opposed to pretty pictures. No technical
with
content.
no thought into... Right.
No technical content.
In terms of making a comparison between this and things like the Logica VTS, in terms of the design tools you had around you to do this.
I don't even know where you're coming from.
So, what did you have at this time to design a product like this in comparison with what you had to do with the VTS?
It was 3D CAD.
Right, okay.
3D CAD.
Yeah, absolutely.
Board information in skylines, all the components, and then clad it, if you want a better description. But it's obviously as light and as thin as structurally sound.
Not tested down the road by falling out of a pocket and hitting the street.
No, well, there's some tests you can't really
That's right.
mimic. So as we've been speaking today from the Logica VTS, you're designing a computer there, but this is all being done by hand, drawing boards, the whole works. Now with this, you're using computers to design computers.
Absolutely.
And it's a whole different ballgame. Which do you prefer?
No, today.
You do prefer today?
Oh, absolutely.
Yeah. Okay. So
we both sketch, we both draw.
So there's still an element of the whole process.
Absolutely. Yeah. So because you only want to utilise the CAD, 3D CAD, for what its strengths are. You don't want to play around with it. You take what you're doing and put it in.
Right.
Analyse the process beforehand and tick boxes 10 out of 10. You will take that, all I would say to you, like I have in this past week.
You sketch concepts. Sketch your concepts and discuss your concepts before you go anywhere near the CAD.
Right.
Yeah, and I say to him, Ian, we need at least 3 versions of clip. Yeah. And why 3? Try and do it with 1. And what's the precedent out there? What applications in the marketplace are similar that we can not invent the wheel. Inventing the wheel is extremely expensive.
Absolutely, yeah.
So for me, it's like, okay, where's the nearest comparison we've got? And then we use that because there's strength in that, because we can also show the client that this is what we're doing. We're being influenced by something that already exists, that you can see, that works for its application, and we're taking an element of it and putting it in your application when it's mechanical. When it's not mechanical and it's subject to emotional decisions, then the client's got to make models and take them out and show a number of people. And they give feedback.
How much of this is emotional?
Oh, good point. Not a lot.
No?
No, let me finish.
Okay.
I'm thinking the basics are not emotional, right?
What are the basics then?
X, Y, Z.
Right, okay. Dimensions.
Dimensions.
How much it weighs.
That's right.
Right.
The keyboard supplier.
Yeah.
And we need to be able to talk to the keyboard supplier as to what he can change if necessary or not. And at the end of the day, it's the detail that makes the difference, because anybody can come up with the overall shape like that tadpole shape there. But it's the detail, and I'm going to show you. And this one's easier. Consistency of this vent, for example. The fact that we're repeating that detail with the slope going up there. The light curve on here and the little pimples on there are a tactile feedback condition. So, you know, it's those details that make the difference between a good product and a bad product. And most people don't acknowledge that. It should go subliminally anyway.
Yeah, I was going to say, sometimes it's not there to be recognised.
Having told you all of this, you know, I want an introduction to the client. So I can see you're yesing me all the time.
I would love to introduce you to the client. If I get the opportunity, I would 1,000% do that.
No.
But,
pull on your leg.
Well, they'll go online. Hopefully, there's a potential product out there, a client out there. But it's just very, very interesting. There's the grid computer. It was it went on the space shuttle. As he lifted the lid up, there was a little area at the sides here that would become accessible, and things could go in them. So, you know, paper clips or whatever. And it was really important to spend a lot of time there. As it opened it, the lid would scoop out whatever was in there to make sure that it didn't get caught up.
It's those details.
It was beautiful. I loved it. The fact that so much attention to detail was put on something like that.
That's right. That's the differentiation between when you're in a competitive market with products, and there's a lot of other products similar to your client's product. That's what you've got to find. You've got to analyse that. Some clients don't want to know. Well, sadly,
no.
And that's why at the end of the day,
which would be a financial thing. They don't want to think you've spent your time, wasted your time.
That's right.
Doing little things like that.
Whereas at the end of them, they don't last that long in the marketplace anyway. And to be fair to them, a lot of them do the development and create the product only to be sold on as a company and move on.
Yeah, some companies exist for different reasons.
That's right.
But
and I respect that.
But it's interesting when you mentioned that
tell us in the beginning.
Yeah, it's interesting. The angle there is the same angle as
and you see,
I never,
there's an angle there as well, which copies those, and the angle back there copies that. And this has got a dish in it, which is tactile. Yeah, same stuff. I'm glad you're spotting.
Yeah, I'm really intrigued by it.
This clip is rubberized at the top here. It's not hard. It's not magnesium.
Yeah, that's sometimes a problem 30 years down the line.
Peels off.
Well, the rubber just starts to go to goo. Rubber in
this
the
doing quite well. It's not that was doing
fine. Yeah, that was doing fine.
Respect it, right?
It's an interesting. I'll bore you with a little bit of it, but it's an interesting part of what we do is understanding the materials that we have in the collection.
Yes.
Because they are all degrading. Everything tends to entropy. And we're dealing with products that have a different number of different materials in them, and we've got plastics that are going yellow, which is a big problem. As the bromide sort of disappears in them, they turn this horrible yellow colour. And we're dealing with rubbers that are then just turning into sticky goo. Rubber rollers within tape drives you know, that's a disaster. You know, you put a tape into it and all of a sudden it's unusable. So understanding how all these materials then break down over time is something that we're now dealing with as an accredited museum, looking into how you can't necessarily stop it, but you can slow that process down. So things like that, we have, nearly said quite a nice, I'll stick with quite a nice little PDA from Amstrad, believe it or not. But the case of it is just a sticky, gooey mess. You know, you can hardly get it out of its polystyrene case because it is just stuck to it. Great at the time, nice little feel to it, made it a bit different from anybody else's standard plastic case, but it didn't stand the test of time. So there's not many of them, and they are all big sticky messes. But anyway, thank you very much for taking us through this. It's been incredibly interesting, and we really appreciate you donating these to the museum so that other people can come and see them, and hopefully watch this video and get insight into the background.
Yeah.
Thank you very much indeed.
That's okay. Pleasure.